Hey guys, welcome to Data Structures Hack. Over here, we're going to learn data structures and related problems in a pictorially represented fashion. Please subscribe to my channel and give a thumbs up to the video if you like it. Also start following on Instagram at datastructures.hack to get to know more updates on what's happening on my channel. Let's jump onto today's video, Q. It is a linear data structure where the operations are performed in a particular pattern. What is the pattern? It is first in, first out. What does that mean? It means if an element is inserted into the queue, it is removed from the queue first. So whatever goes in first comes out first. Let us see how it can be pictorially represented in the following example. I'm going to use these two pointers, green and purple pointer, to denote the front of the queue and the rear of the queue. The front of the queue is always going to point to the first element in the queue. There might be a few elements deleted from the queue, but it doesn't matter. It always points to the element which has been in the queue for the longest. And the rear is always going to point to the last element in the queue. The queue doesn't have any specific capacity, so you can keep adding as many as values you want, and the rear would just go on pointing to whatever was the latest element that was inserted into the queue. We are going to use terminologies like NQ and DQ. NQing is nothing but adding into the queue, and dequeuing is nothing but removing from the queue. We can also see whether the queue is empty if the front pointer is not pointing to anything. If there is no element in the queue, then it would say that the queue is empty. Also, we're going to look into how Q can be implemented in the future videos. So stay tuned for that as well. So let me jump into this example. I'm going to move the green pointer to somewhere over here so that I can go on and add the values, and I can show how the pointers are going to point. Also, I'm going to use a card like this, which is gonna show me that it is in the queue, and a value on top of it, which is gonna represent that particular value or the element's value basically. So let me go ahead and NQ the first element 10 into the queue. So now the front is gonna start pointing to 10, and also the rear will also be pointing to 10, since this is the only element in the queue. So the front and the rear are pointing to the same thing. Next, if I want to insert another value, say 4. So if I'm NQing 4 into the queue, the rear pointer would just move and the 4 would just go behind 10, and now the rear starts pointing to 4 instead of 10. So rear is always pointing to the last element which has been inserted into the queue. Next, let me go ahead and insert value 5 into the queue. So I'm NQing 5 into the queue. And now rear starts pointing to 5. So this is NQing. What happens when we start dequeuing from the queue? So if I say dequeue on this particular queue, it would go ahead and remove 10, and 10 can be 10 is no longer in the queue, and the front starts pointing to the next element, which is 4. If I do the next dequeuing, it would remove 4 from the queue, and the front will start pointing to the next element in the queue, that is 5. And if I go ahead and remove 5 as well, if I dequeue 5 as well, front is not pointing to anything, and front is basically pointing to rear. Rear and front are pointing to nothing basically. So this state, you can figure out that the queue is empty. If front is not pointing to anything, then the queue is empty. So this is how the queues principle works. In the future videos, as we mentioned in the beginning, let's see how the implementation of queue can be done. Thank you so much for taking time and watching the video.